Okay, good evening, everybody. My name is Bernhard Gscheider. I'm running a bit late because coming on after Tessa is a bit like coming on after the Rolling Stones. Everybody's exhausted from all the encores that they did. Yeah, but glad to see you here. It's going to be a short presentation. There are only 196 slides in it. I'm going to explain you the reason. I'm not going to read all the slides to you, but you should have afterwards I hope, an overview. Because this presentation was designed for 1.5 hours and time was even too short for that. So this presentation is about two of my open source projects. It's about swak4Foam and PyFoam. The reason why I wrap them up together is that I usually use both of them at the same time, and I find it hard to explain one without the other because they complement each other. Yeah, the intended audience for this is basically you people who have already used OpenFOAM a bit, have not used these packages yet, and who are interested in using them to make your life with OpenFOAM easier. Theoretically, all the steps can be reproduced from the slides. That's why I will be going over certain slides quicker, where I say, okay, here I do this. That's the section where the miracle occurs, and then we go on. So you should be able to go through them step by step by yourself. This is basically the fifth variation of this presentation. I would have liked to have written a new one, but yeah, I didn't have the time. And I usually hold a second training presentation at the workshops, which I didn't have time to either. So I will point you to a lot of the other training presentations that I held previously, where some of the material that I will show you will be extended. And I hope that this is the last time that I hold this presentation. Next year, I will have a new introductory presentation. And please, if during the workshop, feel free to ask me about details, stuff, what your problem is and how, if I think that that swak4Foam, for instance, can help you with this. These slides, that's an example for a slide where I will point you to an older presentation. That's, for instance, I used to have another introductory presentation that had more abstract examples and wasn't just a assembly of cases. Yeah, it was not that good, but that's how it looks like. There's down there, there's an URL where you can download it, and if Bitly goes out of business, then that's the full URL that you can get the presentation at. The presentation will follow a story. The story is about Ignaz Gartenschil. Ignaz is a CFD engineer. I had him in my very earliest presentations. I then phased him out, and then seems to have been quite popular. So people asked me to include Ignaz again. So, yeah. Ignaz is, as I said, he was not here for a couple of years because he was a pogo dancing instructor, and then that business ran out due to COVID, so he had to go back to CFD engineering, and this explains the story of his first job after he went back into the CFD business. It should be a hands-on tutorial. Obviously, we don't have power plugs here, and we don't have the time. And that's why I will be going through it a bit faster. My name, as I said, is Bernhard Gscheider. I'm working with OpenFOAM since it was released as OpenFOAM, not with Foam before that. I'm not an enthusiast, although because I know too much about OpenFOAM, but I like working with it. My involvement is that I'm the janitor of the OpenFOAM wiki. I developed these two packages, and I'm in the committee of the workshop. And these community activities are usually collateral damage of my regular work at Heinemann Fluid Dynamics, which is a small consulting company for developing. We mainly do developing solvers for special applications. So customer comes to us, says we have this problem, we need these physics implemented, and we do that. So the two things that I will be working on, that I will be showing you, is PyFoam. PyFoam is to me, it's a library. To the regular user, it's usually a bunch of utilities that he can use. But in theory, you can use it to program your own utility or to program your own scripts to control your OpenFOAM runs. PyFoam, the library, has a complete parser for the OpenFOAM file format, so it can read in an OpenFOAM file. It understands this OpenFOAM file. You can manipulate this OpenFOAM file because then it's a Python data structure. You can manipulate it like a regular Python dictionaries or lists. If you know any Python, then you know how to do that. And then you say, okay, write the dictionary back out, and it will write out a dictionary that OpenFOAM will understand. The only thing is that it looks a bit uglier, but that's another thing. And based on this library, there's a number of utilities for case manipulation, for running simulations, and for investigating the results. And these will be the main thing that I will show you here in this presentation. All the utilities start with PyFoam. So if you want a complete overview, then you type PyFoam, then you type tab in the shell, and you will have a complete list of these. I usually do this as well, because I usually forget what I wrote 5 years ago. There was a training presentation only on PyFoam that is a couple of years ago in Korea. It has some, as I said, separate to have a separate presentation from swak4Foam proved useless, because I had to do that. I had to intersect them there. It has some interesting advanced topics like putting case files under version control, which is something I find very useful to have. Basically, I'm not a Git guy, I'm a Mercurial guy, but basically to initialize your case, when you initialize the case, to make it a little Git or Mercurial repository. And then that way, all the changes that you do to your case files can be tracked back. Of course, you must be sure not to include the results in the Git control, but that's a nice aspect of that presentation. That's why I put it on here. Another thing that I won't be showing you here is that's a picture from that presentation. That's PyFoam display block mesh, which is a utility that basically only reads the block mesh and shows you the blocks. It shows you the cell numbers. If any one of you had the unfortunate, had to edit a block mesh with more than 3 blocks, then you might appreciate that this might help a lot. So basically, you have this open, you have the text editor open, you tell him to reread, and then you see, okay, that's why the order of the vertices is wrong. swak4Foam is the South African guys say swak means something completely different in South Africa. For me, it means Swiss Army knife for OpenFOAM. It's like I usually say, Swiss Army knife is a very, very versatile tool if you want to cut a rope, if you want to do some things, if you want to do something quickly. If you want to do then afterwards the real heavy lifting, you've got to get the chainsaw. So basically, sometimes if you come to the limits of swak4Foam, then you have to write your own C++ code. But swak4Foam tries to eliminate the need for any special case-specific C++ code, like for instance, that you say, okay, I need this very, very special boundary condition where the boundary is moving over time and inhomogeneous, and I've got to write the C++. Usually you've got to write the C++ object for that. Later then came the coded function objects, but it was C++, and the goal of swak4Foam is to make these unnecessary and keep the dirty stuff like, does it work in parallel and things like these from you. The core of swak4Foam are so-called parsers. A parser is a little part of a program that reads a text and basically translates the text into something that the computer can understand. So basically, you write t minus 273.15, and the parser says, okay, there has to be a field t, that's temperature, and I subtract this, and then I return the result. And in swak4Foam, you can have these expressions on fields, on boundary fields, and on a couple of other things like phase sets, phase zones, cell zones, even Lagrangian particles. And there's a bunch of utilities, function objects, and boundary conditions that are based on these. And I will show you those that cover, in my opinion, 90% of the use cases, but there's a lot of them. As I said, there's also a standalone training on swak4Foam from it was not as good as a training, but I'm still very fond of it because it had only Star Wars themed examples. If Star Trek aficionados are here, I'm sorry. Such a presentation was planned, but I didn't do it then. And explain some things that I think I haven't explained in other presentations, like simple searchable surfaces. That's searchable surfaces, but you can do, because at the time when I was writing this, there was only a searchable surface for a sphere and a cube, I think, and nothing apart from that. And it explains how to generate bind data. That's a longer topic. Some of the stuff that were simulated there was here reenacting this scene from Return of the Jedi, where the Lagrangian particles represented, there were Lagrangian particles here and represented the people being thrown into this pit. And there was a simulation of sand speeders, and these sand speeders were built with these simple searchable surfaces, so that this was done without a cut tool or anything like this. One of the reasons why I promote these presentations is that with swak4Foam and Pyform, I try to be backward compatible. So backward compatible means that even if I think that this behavior is strange, or if this name is not good, once I have released it, I don't change it, because people who use it, I think, have the right to not have their cases broken just because I think, okay, this name is better. I mean, apart from for changed behavior, I mean, if it's an obvious bug, then of course I fix it. But apart from that, I try to have everything the same behavior. For the same reason, in Pyform, for instance, it works perfectly fine with Python 3, but it still works with Python 2.7, because for some people can't have a newer Python version on their machines. I mean, the clusters who are on old Red Hat versions where Python 2.7 was the newest thing you can get are phasing out, of course, but I still support these old Python versions to make it easier for people to deploy Pyform without having to ask the system administrator, please, could you get me Python 3.10? It's the only thing that Pyform supports. Okay. Yeah, I'm going to go. that's basically, that's how command line examples will look. That's basically when it's in blue, that's the stuff you type in, except for brück and cont. And the output will be shown down here in black. Yeah, we don't need that. There is I prepared a Docker image where you have PyFoam and swak4Foam. The last version, it's a Docker image based on OpenFOAM 9. swak4Foam and PyFoam are installed in that, and there's also the example files that I will show you, that those are also in the Docker image. Basically, what you will have to do is just say Docker pull and this name. Then I have a special script that makes it easier to run this, to run the examples. You have to pull that, download that one with wget or curl, and then to start the container, you just say, okay, run container and this, and it basically opens a shell, and inside of the Docker container, you're automatically in the dictionary of the host machine, in the directory of the host machine that you're in. If you haven't worked with virtual machines yet, that's a bit hard to understand, but yeah, I can explain it to you afterwards. Okay, so that's what it looks like to start the container, and in the container, then there's a directory. Okay, there's a directory examples where all the example files that I used can be found. I did that with another side project of mine that I used to. I don't know if you know Ansible. Ansible is something for system administrators that helps you set up your machine in a certain way. And I wrote a Ansible script that basically enables me that basically does it. I say, okay, I want OpenFOAM 7. So it downloads the OpenFOAM 7 sources. It checks that everything that you need to compile the OpenFOAM 7 sources are present on the machine. And then it compiles the sources. And so basically, if I want to pollute a new machine with an OpenFOAM version, I go to this Ansible script and yeah, I started, and 3 hours later, I have the OpenFOAM version that I need on that machine. Sorry? No, Ansible is not similar to Spack. Ansible is something more for system administrators. It can install system packages, create users for you, and things like this. Okay, as I said, getting the material, and you can even get the material without the Docker script. You just have to download this archive file. The first thing usually when I go to a machine is to say, is this machine in a working condition, which basically means, is there PyFoam? And to check which PyFoam, I usually say, okay, PyFoam version, that's a utility that basically looks which version of PyFoam is this, also which version of Python, where's this Python interpreter. Basically, I put all these things in because it makes it easier, and PyFoam version is down here, because it makes it easier for me to support people if they have a problem, because a lot of these problems are, there is no Python. So basically then the utility tells me about this, or it doesn't use NumPy, or it uses the wrong NumPy, and that's why I then have a list of the installed libraries. Yeah, then I make sure that swak4Foam is installed. That's basically, I just say, okay, funky set fields, and then I get this, and down here it prints me the version of swak4Foam that is installed on this machine, in case there is a feature missing or things like this. Okay, so but now let's go to Ignaz's problem. Ignaz is working now for a company called Warm Rooms Limited. It's a small company that tries to have innovative ovens. One of the oven designs is that they try to optimize the heating of the room by moving the oven through the room. And for the initial simulations there, they say, okay, we've got only experimental data for a little cabin. And Ignaz remembers that in official OpenFOAM, there is a tutorial case that he might use, which is a single room with a heater just on the floor. And he decides that he will adapt it and use swak4Foam and PyFoam to make it more complicated. So what he does is he starts the first PyFoam utility, which is called PyFoam clone case. That's basically when PyFoam clone case basically copies a case to a new location, but it does so by selectively just copying the files that you really need to set up the case and to start the case. It says, okay, there are 7 terabytes of simulation data there. I will ignore these. I will just take the constant system 0 and the initial additional dictionaries, directories that the user specified. So then usually what Ignaz uses for preparing the cases is, of course, there's always these all-w run scripts in the tutorial cases, but Ignaz usually ignores them and says, okay, I'm going to use PyFoam prepare case because later I will be a bit more flexible when using that. So basically for this simple case, start PyFoam prepare case. If there is no other information on how to set up the mesh, then PyFoam prepare case, for instance, assumes, okay, this is a block mesh case, so I'll run block mesh. And it copies the initial values. What I won't explain today is then it looks for templates in these files. Templates are basically more general case files where I can do evaluations in these case files and prepare case for that. But yeah, that's what it does. There are 2 trainings, or basically it's 1 training, but it's 2 very different versions of PyFoam prepare case. One is from the 10th workshop. The advantage of this version is that there's a lot of cat pictures in it. The second one was from the Shanghai workshop. The advantage of that one is that it was proofread, but the cat images were removed. So pick your choice what you prefer, correctness or cats. I know that's hard. That's, for instance, that's one of the things that are explained there, how to use PyFoam prepare case. That's for instance where PyFoam prepare case is used to set up the Pitts daily case. It can basically, for instance, one of the problems with the Pitts daily case, if you want to compare different OpenFOAM versions, is that different OpenFOAM versions, for instance, have slightly different formats and they are incompatible for things like even the viscosity that used to be quite different in older versions. And with PyFoam prepare case, you can at least write templates where you can use still the same case files, and the templating mechanism adapts them to the OpenFOAM version that you're actually using. And in that presentation, then I showed how to for instance, how to use PyFoam prepare case to do tests on different mesh resolutions and how the detachment point of this backward swirl changes due to mesh resolution and how it's different between different OpenFOAM versions. Spoiler, I hope, if I remember it correctly, the spoiler is detachment point is for the same measure resolution is the same for different OpenFOAM versions. It changes slightly with the measure resolution. Okay, but now there comes the interesting part. Ignaz starts the most used utility in PyFoam. He starts PyFoam plot runner. That does the two things that it says in the names. It runs the case and it plots stuff. I usually say that PyFoam implements the thing that I was missing most, or the only thing I was missing from Fluent, that was having windows open with the residuals and watching the residuals while you drink your coffee. And that's what PyFoam plot runner does. There are some options. The interesting thing here is usually here you specify the solver to use. If you specify auto, which people with a bad memory like myself, when I don't remember which solver is supposed to run this case, it looks into the control dict, because usually in the control dict there is this entry solver, and it says, okay, it takes the solver from there and runs that one. Okay, so it runs through, and also what I do here is, for instance, I use clear. Clear basically removes all the old results, so I don't have to remove them by hand. And with progress, I say, okay, I get the residuals plotted anyway. I don't need them printed out on the console. So sometimes later, then it ran through the case. That's still the regular tutorial case. Here you see the residuals, continuity. These are the things that are automatically plotted. So sometimes Ignaz closes the plotting windows and then says, I forgot how they looked like, but I don't want to rerun the complete case. And for that, he uses a utility that's called PyFoam Plot Watcher. The PyFoam Plot Watcher, you just give a text file to it, and it interprets it as the output of an OpenFOAM run and plots things. And one of the things that comes quite handy here is that basically the PyFoam runner automatically took all the output that would have gone to the terminal. He took it and put it into a separate file that was called PyFoam runner, name of the solver and the log file. So if you run two different solvers on one case, then you have two different logs. For instance, if you want to compare what does row central foam and row pimper foam, how do they compare on this case? And plus there is, for instance, here is the option hard copy that here I tell that tells GNUplot, who does the actual heavy plotting, to write out bitmaps with the plotted graphs. So basically he runs it, and then he just takes the PNGs from the disk and inserts them into his presentation. There are alternate ways to control the solver. Basically, PyFoam in parallel runs a little server which you can contact through a little command line interface, where you can basically tell the solver to stop, and PyFoam then basically manipulates the control dict so that OpenFOAM writes out the last time step and stops after the time step. That's quite nice when you say, okay, he will take another hour until he gets to the next regular writing of stuff. But I've got to stop it now, and I don't want to lose the 3 hours of calculations that he did without writing a time step. Then that's where this is quite handy. Okay. So yeah, I'm going through this a bit quicker. That's one of the things, is that Ignaz understands that it's important to have colorful pictures to show around, but he doesn't like to click in ParaView that often. And so he uses two things. The one is the ParaView state files. Who of you has ever worked with ParaView state files before? The other ones, please try it. It will save you a lot of time and a lot, because it's not fun to always click the same 5 filters. And what PyFoam brings to the party is basically that you don't even have to click to open the state files, but it's a utility where you say, this is the case, this is the state file. These are the times for which I want pictures. Please create me pictures with this state file. So this looks like this PyFoam snapshot. The dot means the case in the current directory. This state file, I want time 200 and I want the latest time. And so usually it's a good day when I can say, okay, I never had to click in ParaView. I generated all the necessary pictures with this. And the other advantage that PyFoam can take no credit for is, the nice thing about state files is that you always get the same angles. All the stuff look exactly comparable. And one other thing that it does is, for instance, if it finds formatting expressions like this in the text strings that you inserted in here, is that it automatically inserts the name of the case, for instance, in these. That's quite nice, because that way you can immediately have your pictures labeled if you use them for internal reference, for instance. If you're more interested in what I call mouseless post-processing, there is from the Portuguese workshop, there is a presentation, PyFoam for the lazy. Of course, none of you will feel like the target argument, because I see no lazy people here. So I think from the marketing standpoint, the better name would have been PyFoam for the efficient. That's you, right? And basically that explains some utilities that are in PyFoam where I can get, for instance, data out to from sample lines, how to write data immediately into Excel, because you want to do this in Excel or CSF. In this case, the example that I show you here is that there was this case where Lagrangian particles were added, and then then basically the positions and everything from these particles were written out into a pandas data frame and analyzed in this pandas data frame what is the location of these Lagrangian particles, for instance. Another thing that's a small utility, that's I call it field report. That's one often you just open ParaView because you say, okay, what was the maximum temperature in this simulation at this time step? And that's all the information you're interested in, because you know your case well and you know where the temperature will be. So basically you can say, okay, field report, the name of a field and at which times, and swak4Foam will write you out some basic statistics about the field, like what was the volume of the case, what's the minimum, what's the maximum, what's the regular average, and what's the weighted average. The weighted average is basically the cell size weighted average. Yes. The question was whether this was added, if this snapshot was done with PV snapshot. Yes, I think it was, because on my own, I usually, because here the solver information was inserted. And the Lagrangian particles were added in swak4Foam with a special function object that adds Lagrangian particles to any solver. No, no. Okay, no, for that, okay, we'll discuss this later. I'm already running a bit late, so it's, yeah. Okay. And for instance, field report, you can even then use it to write out CSV files that you can load into whatever your favorite data analysis thing is. I'm not going to judge you if you use Excel. And afterwards, then Ignat says, okay, I want to throw everything away that is not involved with my work. And for that, he usually uses PyFoam clear case, which basically throws away all the stuff that was not hand edited. So he throws away, yeah, all the data, but all the data that he throws away the mesh. He even throws away the PyFoam generated files, keeps the other stuff. And if he wants it for archiving, then there's this thing that's called PyFoam pack case that generates a tar file with all the necessary files for you. So if you, for instance, if you have a support problem, you can use PyFoam pack case, send it to whoever supports you and say, okay, this is the case, can you rerun it? Yeah, and now we come to the oldest utility in swak4Foam that's called funky set fields. Funky set field is basically it does was what set fields does, but it does it on steroids. It can do it. You can give it any expression, and it will evaluate that expression and write a new field for you. For instance, here what it does is it says, okay, funky set fields. At the time 0 and all the following times, create a field that is called T Fahrenheit and use that expression. I always have to recalculate that expression. That is basically that calculates the Fahrenheit from Kelvin for you. For those of you who are unfortunate enough to have to do presentations in Fahrenheit. Yeah, so you run that, and afterwards you have these fields where you get everything in Fahrenheit. And in the original case, there used to be this box to face on the which basically simulates the heater on the floor of this. And in funky set fields, I mean, it's a bit hard to see the advantage here. In funky set fields, you've got to write a bit. Bit more complicated. The expression is not complicated. The expression says, okay, set 600. What is complicated is to say, okay, don't set 600 everywhere, just set it for the cells for which this condition holds. All the expressions in swak4Foam are basically C++ syntax, with including the OpenFOAM specialities, like for instance the ampersand for the inner vector product and things like this. So if you have done some C++, some OpenFOAM programming, you should be quite at home with these. And so basically what it says here is, okay, if the position, that's a inbuilt function, if the position, the x value is bigger than 4.5 and smaller than 5.5 and then set it to 600. For all other cells, leave the old value that you found here, leave that value in it. So that's quite handy, for instance, to initialize interfoam cases. If you say, okay, I want a sphere to drop somewhere. Yeah. So, yeah. So, of course, that's how it looks like. The problem is now that it sets all the cells, but we want only the boundary to be set. So what we have to do, what I have to do afterwards is to say funky set fields at the time 0 keep the patches, because the patch also has this information that this is on 600 degrees, and only set the internal field to 300. So basically with these two steps, I can do what funky set fields, what regular set fields does. But later on, I can do more complicated things. Another thing for that Ignaz wants is, he says, okay, it's very nice that the solver runs. I'm interested, for instance, in the statistics of the temperature. I want to print out these statistics during the run. So he adds this library. That's simple swak function object. He adds this library to the control dict, and then he adds in the function object, he adds the first function object that's of type swak expression. The swak expression is very general, so I have to tell it now, okay, please operate on an internal field, because swak expressions can also work on cell zones, cell sets, and things like these. Print out everything that you find out printed out, and use the expression T, so basically just the temperature. I mean, here it's not a very complicated. And then when you print out, it can't print out the whole field. Print out these, I call it accumulations. Maybe there's a better name, but as I said, backward compatibility, I'm not going to change that anymore. Print out the minimum, the maximum, the weighted average. So that's the weighted average per cell size. And for instance, the weighted quantile, that's basically the temperature for which 10% of the volume is smaller than this. I really like these quantiles. For instance, if you're going for pressure, you can have crazy, very tiny cells where the pressure has a non-physical value. You're not really interested in that. But if you take the quantile 1%, then you get what is actually meaningful minimum pressure in that simulation, if you don't want to get rid of these cells. Okay, so if it runs with evaluation, then it prints out this expression temperatures, then it prints out these statistics here. And yeah, that's nice. You can look at these log files, but we also want curves. And so for that, I'm not going to explain regular expressions. I'm going to cut to the chase. So if you have any output that is there, you can basically use PyFoam, can match any regular expression that it finds in the output. For instance, here it would be expression temperatures that we know before. It says, okay, minimum. And now I'm interested in what comes after the equal sign of minimum. That's a value I'm interested in. That's a value, that's a value, that's a value, and that's a value. Collect these and print them with the titles minimum, 10%, average, 90%, and maximum. Print them out in this. And so you would get during the simulation, or if you use the watcher, you get it after the simulation, you get these curves. You don't have to be like me. I'm going overboard, and at the end of the project, I have 40 custom regular expressions and corresponding windows going up. Yeah, there's a similar function object that's called patch expression that basically is a specialized version of swak expression, where you can specify a list of patches. One main advantage of this is that in this list of patches, you can use the usual regular expression notation for patches that you maybe know from the boundary fields of your cases. You can use these here too. So basically you can say, okay, wall dot star, and you will get the statistics on all the patches that whose names start with wall. And here I use, for instance, that's a function that is special for patches. Instead of using T, because T has the boundary condition that we have, which is 600, which doesn't give us much information. You get, okay, that's 600. this one uses internal field T. That's basically it for each phase of the patch, it uses the value of the next cell to it, which in this case is much smaller than the actual heater temperature and gives you more information about the actual temperature that the customer experiences. And yeah, there is a bit more general way, if for instance, and the patch expression, it would now print out the wall temperature internal on, and then it prints here, it prints the patch name, and it would be a bit stupid to basically set up a custom regular expression for each of these patches. So basically what it does is you tell it, this is dynamic, this is the identifier, please use this as the identifier, and for each identifier plot a separate curve or a set of separate curves. So you can get plots like these where one of the problems with this is that the GNU plot then runs out of colors that it can show. Okay, I've only officially got 10 minutes, so I'm going to speed up even more. Another nice function object is expression field, which basically creates a new field that is there in memory, and for instance can be automatically written out. So basically at every time step it calculates the Fahrenheit and automatically writes out the Fahrenheit fields, either for post-processing afterwards or for being used by another swak function object. Yeah. Okay. You can use funky set fields using dictionaries. That's the advantage of this, is that you can have more complicated expressions. And one thing that everything that uses swak expressions from a dictionary is that you can have a list variables where you can specify, for instance, for the length of the case, you specify xlength, which is difference between a minimum and the maximum of x, and then use this here, which would be otherwise would be a very unreadable expression. That was for making the case non-dimensional. Yeah, there's a special output mode for the PyFoam watcher, because next thing that's now what Ignaz wants to do. He wants to move the heater around, and for that he uses GroovyBC, which is the second oldest thing. GroovyBC is basically a mixed boundary condition where you can specify the value and the gradient, and with a fraction expression you can tell it, okay, use the fixed value or use the gradient. If these two are missing, it assumes immediately that this is a Dirichlet condition and applies that. And using that, you can, for instance, now easily specify. This specifies that the heater now, instead of being static and in the middle, is a circle, and that circle moves around the room. Yeah. One of the things that can be quite error prone with complicated boundary conditions is, you know how it is. You get a sign wrong, you start the simulation, you start the simulation on Friday, come back on Monday, and on Monday you find out, okay, I got the sign wrong, the heater went in the wrong direction. And for things like these, there's this replay transient boundary conditions. That's something that you can use even without Groovy boundary condition. That's a utility that you tell the utility, okay, please load this field, this field, this field, and this field. Then increase the time, and at each increment of time, correct the boundary condition and write it out. So basically, you get the actually used boundary conditions. You get them written out to disk, and you can then open ParaView and check and say, okay, the heater is going to go in the right direction. I'm fine. I can start the run over the weekend, and it does it because it only changes the boundary condition. It's ridiculously fast. Yeah, these are just some pictures from when the heater started running around. There's two things. One of the things is then usually when you start writing your expressions, you say, okay, there's supposed to be a viscosity field in there somewhere. I want to do I want to evaluate the viscosity field, and the problem is that it's sometimes the name of the viscosity field is different between different OpenFOAM versions. It changed. You don't know what it is exactly. So there's this this function object list registered objects that you can insert. And what it does is every time the function objects are called, you get a list of all the objects that are currently, or all the fields that are currently in memory and can be used for any swak expression. The other one is the banana trick, for which it's a pity I can't claim it's my idea, because there so because, as I said, swak4Foam introduces a lot of function objects. Sometimes I forget which ones are there. So basically, if you want to know more about function objects that are in swak4Foam, insert the type banana into a function object, and you will get a complete list of the function objects that are loaded. So there are already 90 function objects here. I think 5 are standard OpenFOAM and the others are from me. One interesting function object is, for instance, if I want to calculate the heat flux, then I basically insert this field file heat flux in here. I add a groovy boundary condition that calculates the heat flux on this patch. And then what I use is a function object called read and update fields. It reads the field heat flux and updates this field at every time step, and writes them out for post-process, and they automatically get written out for post-processing. So you can use this expression to calculate the local heat flux and yeah, use it, or use it in other expressions. Okay. Yeah, one neat thing is, for instance, one thing that is quite common is, for instance, okay, I need the pressure drop from here to there. And for that, because until now, swak4Foam could only do processing on one separate entity. And for that, you need so-called remote variables, where you use these brackets. And what it does, it tells swak4Foam, okay, this is an expression, but please don't evaluate it on this patch, evaluate it on the other patch. And is there an example here? Okay, you've got to this. Okay, so basically that was the third one. These things, remote variables, and there are other variables. For instance, they are explained in a there's this presentation, state and solution, where you can basically where a couple of things are explained. State machines, where you can have, for instance, you can switch between different states and your boundary conditions behave differently on these states. So the example that I usually explain is, for instance, you have a probe somewhere. You evaluate this probe. Once the pressure or the temperature on this probe goes beyond a certain temperature, it tells a valve to open. Opening the valve means just changing boundary conditions on a certain patch. So you can have in swak4Foam, you can have boundary conditions that depend on the flow. And yeah, one example from that presentation was, for instance, using a regular solver from OpenFOAM, which had porous medium, but didn't have water deposition and evaporation of water droplets. It added these just with function objects without any programming. Okay. Yeah. These are the more advanced things. One of the things that is one of the problems that Ignat sees is that basically these jumps in the temperatures on the wall. These are due to, I said, there's this small circle moving around the floor. The problem here is, of course, is discretization. There's this condition where it says, okay, is this inside the circle? The circle moves on, and then suddenly a cell switches from cold to hot. And that's where you see these kinds of jumps. It's a bit hard to have it more general. I just explain here a workaround how doing first calculating the expression on the points, then interpolating from the points to the cell faces, you get a bit smaller jumps, basically because it's doing some implementation. Another nice thing that you can do with Groovy boundary condition is, for instance, the ESI release, for instance, has this lumped boundary condition where you say, okay, I have this wall, and this wall represents a concrete slab that is heated up by the temperature in the room. And because it is heated up, the heat transfer becomes less because, yeah, there's less to heat up. But this boundary condition is not present, for instance, in the foundation release. So basically, instead of having this lumped boundary condition where you specify the mass of this the CP and the initial temperature, and then during the simulation it changes that, you can use so-called stored variables. That's something else that swak4Foam has, that's variables that store their name. And basically, using such stored variables, you can have a groovy boundary condition that simulates at these this lumped boundary condition and replicates exactly the same stuff that this boundary condition does. These mapped values and this mapped values, delayed expressions, and things like these are explained in expressive swak4Foam. That's some more advanced topics. For instance, here I explained, here's a case where here's a pressure sensor, here's the outlet, and basically all the mass flow that goes out through this outlet comes with a time delay of a couple of seconds, comes back in up here. So it's and if I remember it correctly, basically once the liquid reaches the sensor, the bottom opens again. Yeah. And another way to add a solid region instead of lumped is there is a rather new thing that I call simple solvers. That's basically function objects. For instance, there's a function object that does the complete heat transfer. So you can add conjugate heat transfer to any other solver just by using this function object. You have to set up a special mesh region and be sure that this, but it does heat transfer in this region. So basically, you can I use it for adding conjugate heat transfer to solvers that don't have it and where I don't want to add it. One of the examples from that presentation that's a more esoteric thing is that, for instance, this is the regular Pitts daily case, and I said, okay, instead of having the regular uniform boundary conditions, I add here a region, I add here a region, and I let it calculate the a potential flow in this one and use basically the velocity of this potential flow, use it as the inlet for the Pitts daily case. Yeah, I think it was 10 iterations faster than without, but it was fun doing it. Yeah, and the last thing that's really hardcore. That's basically, for instance, you have this. That's a regular external wall heat flux temperature. That's a boundary condition that is built into OpenFOAM, and it says, okay, you can have the outer temperature here, and you can have the heat transfer here, and usually you write uniform, and that's all you can usually do, because I mean, nobody knows the order in which patch phase. Nobody knows that patch phase 23 is the patch phase where you want a higher heat transfer coefficient or a lower heat transfer coefficient. It's nice that it's there. I don't know if anybody ever used it, but there is this utility. It's called it's a bit more complicated to use. It's called funky set boundary field, where you say, okay, I have this patch fixed wall. I have this inside of this, I have this field H, and now please read in the field file and replace this uniform thing with whatever the expression evaluates to. And here Ignaz uses this. Here we go. That's how it's specified for that. And here Ignaz uses this to set the heat transfer coefficient for this case on the outer walls to a higher value, because in this case the windows are less insulated, and so he gets heat transfer out of higher heat transfer out where the windows are, and yeah, the results change. There is a certain reason why the flux is wrong. It's perfectly explainable. I have to think about it every time, but yeah, we can discuss it over a beer why this is wrong. Okay. Then you can even have this kind of output for the PyFoam plot runner, where instead of having boring lines, down here it gives you the progress of the simulation, and it even gives you an estimate on how long it guesses the run will take. Okay, so yeah, then as I said, Ignaz avoids programming. He uses swak4Foam and PyFoam to avoid these things, but if he has to do any programming for developing for solvers, there's a presentation, swak4Foam and PyFoam for solver developers, where I've shown some function objects that I have in swak4Foam. For instance, one of the things that I use regularly is I have a function object that basically stores the last, let's say, 20 time steps. So if and writes them out in case of a crash, or in case that conditions become unphysical. So that way, for instance, if the pressure explodes somewhere, usually you just have the crash and you say, okay, it crashed, and now I've got to rerun it and write out every time step. And if you use that one, it basically says, okay, I crashed, I write out the last 20 time steps, and then I can open ParaView and say, okay, that's the cell that caused all this trouble. Mind you, that's a nice feature, but of course it uses a lot of memory. You need 20 times the memory than your regular case, so it's something you do during development. Something that is, for instance, in the form extend and in the ESI thing is the application level profiling, where basically important sections of the code are profiled, how long they take. They write out stuff in special dictionaries on the time steps on the uniform, if you remember it. And for instance, in the presentation, one thing that was explained is how to make a beautiful graph like this, where you can have a look at and say, okay, it was the pressure equation that takes most of the time. So basically that's a graph that says, okay, whatever. It says 84% of the computation time were taken up in this, and so that can tell you where to optimize your code, because it doesn't make sense to optimize setting up the source terms if most of the time is spent in the Lagrangian particles anyway. Another thing is, as I said, PyFoam, for me, it's more a library, and there is a presentation on programming with PyFoam where I explain how to set up a program. I explained it by simulating this kind of water rocket. I don't know if anybody of you has ever built it. That's something I'm very happy to discuss with you over a beer or whatever you drink. That's a plastic bottle that where you fill in water. You have a valve down here. You use a bicycle pump to pump it up, and then you open the valve and it shoots up. And the optimization question was what is the optimum filling height and at different pressures? Because basically the water is pushed out by the air in there, and so you need a certain amount of too few air is bad and too few water is bad. And in that presentation, it's explained how to do a very, very simple interfoam simulation, do the parameter variation, and find out what is the optimum height that you get for certain filling. So basically, I think optimum filling was something about 40%, according to these simulations, which lined up with the experiments I was doing with my niece. Yeah, and also one thing that swak4Foam has is there's a scripting language integration. These are function objects where you can call where you can call snippets of your programming language of choice and use the facilities of these. For instance, the integrations that are there are Python and Lua. Lua is a very, very simple scripting language. It's so simple that I include it in the compilation process of swak4Foam. And then you can, for instance, here I program a particle injector with a Lua function where Lua specifies the positions of particles that are going to be injected into the case. Okay, so Ignat says goodbye. I say goodbye. As I said, there's a question, a couple of other things. Are there any questions? Sorry, I think we are already over time, but I think I'm going to take questions until they run out or Hrv looks angry because we are running behind schedule. I'll just have to check if there are any online questions or other questions from the audience. Let's see. Okay. There is one question here where somebody abused this because he just said interesting presentation. This is very kind, but doesn't help us. Sorry.
I just have one quick question regarding the computational performance when we use multiple ranks, for example. So how swak4Foam or PyFoam would basically perform in this situation?
PyFoam is not linked to PyFoam is not linked to any OpenFOAM code. It just looks at it from the outside. So it doesn't impact it much. It doesn't impact swak4Foam. I don't have any big machines to my disposal. So basically, what it uses the regular reduce and operations to for instance collect information. Yeah, I can't really comment on that.
Can I try?
Yep.
So the expensive part of OpenFOAM is linear solvers, which are 50, 60, 70% of time. So you can have all the luxury of swak4Foam without noticing the excess cost that is evaluated until you run 10,000 lines of Python to evaluate your boundary conditions.
Yeah, I mean, there's all those Amdahl's laws, which says, okay, if Groovy boundary condition, for instance, takes a little time, if you do it on 1,000 million processors, it will impact. But yeah.
Any more questions?
But if you're running such long on such big clusters, you probably have some consulting budget, and I'm happy to have a look at the project, at the problem.
So very brief one, is it possible to set a vector field such as a velocity field with funky set fields?
Yeah, yeah, it is possible to set vector fields. If you're hardcore, you can even set tensor fields. These are just more complicated expressions. Yeah, but it even knows the different tensor fields there.
Any more, please? Oh, I beg you, one more. May I ask you a question? So you have to support various forks of OpenFOAM, and how much effort is that? Is that driving you crazy, or is that manageable?
It depends. The foam extend guys have been very kind to me. They haven't released for quite some time. Then the next biggest in effort is the ESI release. The ESI release isn't much work because the ESI release basically, I mean, they assume that people use their code so they don't break anything without any let's say, necessity. And foundation release is always a bit of a big, because they like to refactor, they like to rename things. To be honest, I just finished porting last year's flavor because I was looking at the Lagrangian code, and then I decided, okay, I'm not going to support Lagrangian particles in the foundation release because they completely rewrote it. They probably have their reasons. It probably has its merits, but how should I say it? I usually use for my project, I use either extend or the ESI release. So I try to keep my workload low there. If that's a problem for somebody, please contact me. But yeah. But the majority, the features that are here, they are still supported in the foundation release.
Any more questions?
Thank you for the talk. I have probably a very silly question. Any version of swak4Foam and PyFoam works with every version of OpenFOAM, or do I have to pay attention on compiling different version on different version of OpenFOAM?
The thing is, so basically what I publish in the Mercurial repository is the development version that usually compiles with the current versions, and all versions, basically I test it with the current versions of the three major branches. And for completeness, I compile it also with OpenFOAM 2.3. And then I assume that I haven't broken the intermediate versions.
Okay, so if I am currently using the V2006, so I can use swak4Foam without any problem.
2006. Yep, that works because.
Okay, thank you.
Yeah. That's part of the backward compatibility promise that I talked about.
Any more questions? In that case, please allow me to thank Bernhard for his continuity and for his work.
Thank you very much.